Development of application which is native to clouds is hard, right? Hard. That's why there are many tools which are provided by our cloud providers in order to make our life easier. And the tool we are going to talk about today is SAM. A few words about myself. You know who I am. I'm Alex, chief engineer, and I'd like to start my talk with a small journey to serverless, where we started and where we are right now. If you take a step back, for example, 5 or 10 years ago, we will see that at that moment, our software was mostly deployed to hardware or virtual machines. It was possible to deploy our, oops, text is a bit messy, right? Right, okay. Something went wrong with PowerPoint. That's why it displays part of the text properly, but part of the text is not properly. Okay, nevertheless, so it is possible to deploy our software as a big deployable unit, as a big jar to the big hardware machine. And if we need more resources, we can buy more powerful device and build and put our software there again. But at some point in time, people noticed that it's not really efficient. We have many software and it's necessary to have separate hardware or separate virtual machine for a separate piece of software. That's why we decided that it's better to multiply virtual machines using VMware, E6i, using Xen, using KVM and other virtualization technologies. It allowed to utilize hardware more efficiently. Of course, this kind of containers for your software is still available in clouds, like Azure virtual machines, Google virtual machines, Amazon EC2 instances. But what we have right now, what we're moving from right now, we're moving from containers. When every piece of software, every small piece of software is packed into the container, and this container is self-sufficient. Like if you need to run Nginx, you need to download container to your machine and start Nginx, you will get it. If you'd like to deploy your software easily and scale it to the great scale horizontally, what you need to do is to build a Docker container and run multiple of them. We have Docker Swarm, we have Kubernetes, we have managed platform like Elastic Container and Kubernetes services, which allows us to do it easily and scale up to the great moments. Well, in this case, we are losing some kind of control. We cannot configure everything we need on our hardware. But on the other hand, became more focused on the development. There is no need anymore to configure your hardware from the very beginning. You can just rely on the orchestrator. What if we try to move forward and try to focus on our code instead of running even containers? We have serverless right now. This is the, let's say, the last one, the cutting edge technology, which allows us to focus on a very small piece of functionality, like a function which receives some input and produces some output. And it does not matter wherever this input came, whether it came from queue, whether it came from maybe REST, wherever. We have serverless. And in order to build these serverless applications, it's necessary to write much more specifications. For example, you need to build deployments pipeline. You need to build a specification which says how exactly to place your piece of software into the overall architecture, where you will get requests, where you should put your responses. It's necessary to build more specifications for it. On the other hand, it has very significant benefits. Because first of all, you do not need to think about infrastructure. Infrastructure is provided for you. As many workloads you have, the more you pay. If you do not have workload at all, you're not paying. You pay as you go, and it scales based on your workload. Compute is not one single thing which is currently, for example, in Amazon is provided as a serverless. Yes, we have there Lambda for Lambda functions. We have Fargate for running container as a serverless when we are paying and scaling based on our workload. We do not need to run instances all the time. Speaking about clouds, there are many other features which are provided as a serverless, like step functions for orchestration, message bus, API gateways, and so on. And even storage is currently provided as a serverless. You pay as you go. In order to do everything here, you need to write specifications. What kind of specifications? Well, speaking about cloud in common and Amazon in particular, you need to use CloudFormation. CloudFormation is just a template which describes how exactly you should create your infrastructure and how exactly provision resources by your need. In the best case, CloudFormation template is just a code written in YAML or JSON, and it is controlled, replicate, and it allows you to version uh, this template as an ordinary code. You can even use best practices like code review with your colleagues. That's absolutely fantastic. And for example, include it into your build pipelines. Like you're committing your CloudFormation template, and right after it, this infrastructure is deployed. And of course, it costs nothing to use, supports many things, and template of the CloudFormation is quite comprehensive. On the one hand, it's comprehensive. On the other hand, it's quite complicated. As you may see, it consists of many things. And in order to deploy something into the cloud, you need to write almost all of them. Like you need to include header, it is not mandatory, but it's recommended, which will describe what is in your stack, what it contains of. Parameters of mappings if necessary, conditions if required, and the main part is resources. If you ever had the opportunity to deal with CloudFormation template, you know that they are very verbose and very complicated to write it properly. That's why we have SAM. This is a bit simplified way of writing for templates for serverless applications. What is SAM? On the one hand, SAM is just an extension for CloudFormation templates, which allows us to build the same functionalities, the same resources which are required for CloudFormation, but in a bit easier way. On the other hand, it is also a CLI, which allows you to do many things automatically, like start a new application, deploy it, and deliver, and of course, repeat. And also, it provides a lot of things uh, out of the box. First of all, it of course single deployment configuration. It is a very interesting thing, and we'll go through it today. So what does it mean single deployment configuration? It means that your code is deployed together with your infrastructure. So the CloudFormation allows you to create your infrastructure, but in order to deploy code, for example, to Lambda, what you need to do, you need to create S3 bucket, for example, upload the code there and run the application, right? Right, deploy Lambda. But using SAM, you can do everything at once. It will pack Lambda for you, upload it to S3 bucket, and create a Lambda function. What else is allowed? Also, it has a great CLI which allow you to invoke your Lambda functions in a very similar environment to which they will be invoked later on. And of course, it allows you to have some additional integrations with code deploy, X-ray, and so on, and store some intermediate configuration and files. Also, if you're using SAM, of course, you can do everything you're doing together with tools which are available for you in cloud. Okay, 10 minutes of slides and I need to go to the console, right? Right. Colleagues, if you're still with me, please put something into the chat just to make sure that I'm not losing you. Or for example, raise your hand if you see me, if you still hear me, still see and hear me. Yeah, okay. So my journey to the SAM starts with SAM command or SAM CLI, which I can install and I can use it easily. In order to start using it, I need to do one single thing. type just SAM. In order to start a new project with SAM, I need to execute SAM init. And next it will ask what I'd like to use as a starting point for my application. Well, it is quite straightforward thing, but there are two opportunities here. I can use my own template for the SAM serverless application, or I can use a template which is provided for me by Amazon. And also there are a few templates like serverless API, schedule, task, standalone function, machine learning, hello world. Let me use hello world. And it asks me to use most popular runtime and package type. No, I do not want to use the most popular runtime. For example, I'd like to use Python for this, and I'd like to package my Lambda functions as zip or image. If I choose zip, my code will be packed into the bundle of type zip uploaded to S3. If I choose image, it will be packed together with some Docker runtime and uploaded to Elastic Container Registry. So as for my example, some example test one, it means nothing. What's happening next? Same example. Same example test one. What I have here. Here I actually have a few files, and let me show you these files. What's inside them? Code point. Yes, this is what was generated for me by the SAM CLI. As you may see, the main things here are events, hello world, this is my function, this is entry point into my function. And as for now, it is not important what is there because we will write our own code. But what's more important for us is this. This is template. Template, which is actually not a CloudFormation template, but it is a SAM template. Why is it a SAM template? It is a SAM template because there is a transform section here which says that before using this template, you need to transform it from the SAM template to CloudFormation template. And what's happening here and what is the difference between this template and CloudFormation template? Of course, in the resources section, I have all my resources declared. But as for here, you see that declaration of resources is a bit different. For example, here I'm declare if you'd like to declare a Lambda function in an ordinary way, you have a few opportunities. And in common, you have two opportunities. First of all, you can write your code in line right here and say, properties, this is my code technically, actually, and I will write my code right here. Another opportunity, another option is to use code which is uploaded to S3 bucket. And here, speaking about SAM, I can say that actually my code is stored locally. Which is more important? Yes, my code is here in the hello world folder. And I will use Python 3.8 runtime in order to start it. This piece says that when I start building my my stack, SAM for me will build a bundle. And when I start deploying it, it will upload my bundle to S3 and next create a function of it. We will go through it shortly. I will show. Another important thing is that it allows me to easily integrate my function with some endpoint. As for here, it says that, okay, this function will be called whenever you're accessing API. Of course, it is about API gateway, and whenever you access the hello endpoint with request of type get, this function will be called. If I do the following, like a SAM build, it will definitely fail because, well, because I do not have Python on my local environment. It says you do not have Python 3.8 because Python which I have here is Python 2. I can say I'd like to build my I'd like to build my functions not using things which are installed on my local machine, but using Docker container. So what will happen under the hood? SAM will download some Docker container, runtime images, as you may see, it is downloading it right now, and build the code inside Docker container. If I'm using, for example, Java, it will download container for Java. If you're using Python, it will download container for Python. If I'm using Node.js, again, container for Node.js will be downloaded. Unexpectedly, it takes time. That's why, if you don't mind, nevertheless, I will show it further, but for now, I will stop it. I will demonstrate it a bit later. Okay, so let's get back to slides. I promise it will not be long slides. I'd like to tell you a little about application which we will build right now. This is a quite simple application. This application is an example, is based on the real use case of one of my production applications. In production, it was a long pipeline, but here I'm implementing a cloud way, only part of it. There is a good site or good web application which is called EuroLex. And this EuroLex site is responsible for publication of legislation of the European Union. You may see this is the site. And what I want to do, I want to download documents which were updated on a particular date or were created on a particular date. Quite a real use case. In order to download these documents, I need to get information from EuroLex API regarding updated documents on a particular date. What I'm going to do next, I'd like to get rid of documents which I have already downloaded. And the last one step is download the documents which are not in my database, which are not in my list. What I will do, what I will use in order to have everything. Of course, these three steps will be simple Lambda functions. Maybe not simple, but I will call them as Lambda functions. Information about already downloaded documents I will store in DynamoDB. Documents as is, I will store documents themselves, I will store in S3. Everything will be orchestrated by step functions, and in order to kick off, I will use API gateway. I hope you have already heard about many components from this list. Lambda, I have already mentioned it. API Gateway, DynamoDB, and S3 are well-known services of Amazon. What's step function? Step function is a thing which allows you to build workflows technically. So what's workflow? Actually, it is like a state machine with a sequence of steps. And every step is actually a state, and state can be of different kind, like task to perform the work, pass states to go to the next step, wait states to wait, for example, until user presses the button in an application. Also, it's possible to run some work in parallel in different states, and it is possible to make state machine decide what way to go, to the left or to the right, and go through one step to another. The main thing here is that everything is declared as a code. And this is the demo time. Let's go through everything and hope now it will be much more interesting for you. First of all, let's take a look into the API which is provided for us by the EuroLex. This API is simple and straightforward. As I mentioned, we need to have at least two things. First of all, we need to get documents which are updated on a particular date. It is simple. We're just sending a request to this endpoint. Voila, I'm providing start date, end date, and I'm getting this long XML document. What's interesting for me is this field, which says that this is identifier of a document which were created between these dates. In order to get second document itself, I need to take this information, tell this identifier, send a second request. And as a result, I will get information about document, like not all its fields, but all its metadata. This is the application I will build. As a Java developer, I will run my favorite wrong IDE. I have two of them up and running. This one, yes. I will use my favorite IDE. It is IntelliJ, and I have already started the application, and I have already started the project, and I have almost everything I need. I have a template, and in this template, I have information about my project. And also I have parameters, which allows me to, for example, choose name for DynamoDB table, choose a name for bucket I will use. The next important thing, of course, is my functions. And I have 3 functions here. They are in separate folder, and all of them are Maven, simple Maven, let's say simple Maven what? Simple Maven project. And for every project, I'm declaring that, well, this is the folder where source code is stored. This is the entry point. We will take a look into it. I need Java 11 for running it, at least half a gigabyte of memory. And what else I'm declaring here? Also, I'm declaring that there are some environment variables, and using these environment variables, my code will know about name of the table, name of the bucket, and also I'm declaring a policy. Because as you remember, my code should write, for example, some data into DynamoDB, and my code should write some data into S3. That's why I need to provide my code with policies. Like if you have an EC2 instance, the ordinary way to do it is to assign a role to your EC2 instance with necessary policies. Here I'm doing the same, but assigning policies to my functions. If you take a look into name of this policy, you may be surprised that this policy actually is not available in the policies console. And you will be right, because as well as, for example, this or maybe that, because these policies are specific for SAM. If I open my console again and start SAM build -- use container, it will be built under the hood. Everything will be built. It will take some time. Despite the fact that containers for building Java applications are already available in my local computer, it takes some time in order to download all the dependencies, in order to download necessary things, in order to generate the template. So this is code of Java. This is declaration of Java functions, and as you may see, they have some environment variables to externalize configuration, and it has some dependencies. Quite simple things. What else is available here? As I said, I need bucket, and bucket is declared as ordinary. I need DynamoDB table. DynamoDB table again is declared as ordinary, but what else? As I said, I will orchestrate execution of my code using state machine, using step functions. And SAM provides me with an easier way to do it. It allows me to use AWS Serverless State Machine. It is a special type of resource which is custom, as well as function which is custom for SAM. But what it allows me to do, it allows me to declare a state machine in this way. So as you may see, my state machine consists of a few states. These are my states: state this, state this, state that. And here I'm saying this is the first state. In the state, I have a type which is type task, and my task is to invoke a Lambda function. And at the moment of writing the code, I do not know the ARN of my Lambda function, right? Because Lambda is not deployed yet. It is not available on cloud. That's why I do not know which resource to call. That's why here in the template, I'm declaring a placeholder ingest alerter ARN. And of course, for other functions as well, I'm doing really the same thing. And here in the template, what I'm doing, I'm declaring a substitutions, which says that, well, when you will build and deploy these functions, please replace the ARNs, these placeholders with real ARNs of functions. And again, I'm declaring that it's possible to kick off the execution just by using simple API call of type post to this endpoint. Let's take a look into the console. As you may see, everything was executed correctly, and what I've got as a result. As a result, I've got a folder called .aws SAM, and let's take a look into this folder. What's inside it? Inside this folder, I have a template.yaml. This is the template which was derived from my SAM template. As you may see, it is much more exposed. There are much more things here: policies, DynamoDB tables, bucket, which is declared, and many other things. So this is another template. And what else I have? What else I have is my code packed actually. This is my code with all its dependencies, and that's actually all. Let's take a look into the code. Right. And before all the code is quite simple and straightforward. It's just if you'd like, you can take a look into it. It is available on GitHub. I will share the link at the end. But let's take a look on the high level what I need in order to write my code, run my code. I mean, run Lambda as is. This is the simplest one function because it does actually nothing. It just takes a message and sends it forward. So in order to do it, I need to have at least one single dependencies, Lambda Java core. If I'd like to have logging, I need to add dependencies to logging framework. I prefer it let it be log4j and slf4j, and also I need this dependency which allows me to send logs from my Java application into CloudWatch. In order to make everything working, first of all, regarding logs, I need to have a log4j.xml file, which actually just a appender of a special appender and logger of a special name. So I have a appender with template. I have a logger which sends everything to CloudWatch. So this is a common component. Speaking about my code, which is responsible for receiving requests and processing it somehow. If we take a look into the template of, for example, alerter function, we will see that here I have a full name of my class, including all packages, and name of the method which should be invoked. This is everything I need. So this is my class. It implements an interface request handler. And this is type of request and response, which is expected to send and receive from this function. What's happening under the hood? I'm creating all the necessary dependencies outside of my execution, let's say not execution environment, but the main method, in order to reuse it in case of subsequential invocations. If my Lambda is invoked from the first time, it will rise up, initialize all the dependencies, and next it will leave for some time in order to receive subsequent requests and do not create new Lambdas. That's why it's recommended to create some heavyweight dependencies outside of the code. And what's happening here under the hood? Ordinary thing. I'm just sending the request and parsing the response. Not really interesting. All other functions are a bit more complicated because they're dealing with some Amazon resources, and in order to communicate, for example, with DynamoDB, I need to have a dependency for DynamoDB. If I'd like to deal with S3, again, I need to add a dependency to deal with S3. Well, where are you? Yeah, here. So everything is here, everything is available. You may ask here, you're using Java, but I do not see the Spring framework, right? Right. Well, if you take a look into the Java as a technology, in common, it is intended to use in a bit different way. So what is Lambda? Lambda is a short-living code which is created created, invoked, and next it is not needed anymore. Speaking about Java, it has a bit different lifestyle, because it is expected that your virtual machine will be started and next it will work for some time in order to get some statistics, and next it will replace your code with some intrinsic and so on. So it requires some time to live. That's why it is not it is expected that code which you will use here is quite small in Lambda. If you'd like to have your code running for a significant amount of time, you need to take a look into the containers. But for Lambdas, you can, for example, try to build a native executable. And I hope this is the topic, good topic for our discussion. We will definitely talk about it. But speaking about plain Java, it's better to avoid using heavyweight frameworks because your code should start quickly and do what it does. Again, if you take a look into the Spring framework, there are many integrations which allows you to write your code independently of cloud provider. For example, you can write your code and next decide, hello, okay, today I will deploy it to cloud A, to Amazon. And Spring will provide you with bindings, which allows you to call your code from Amazon environment. And next day you decide, well, I need to migrate my code from Amazon to Azure. And there will not be need to rewrite your code. You will need just to change a binding. This is a quite tricky and interesting thing. So let's move forward. And before moving forward, as a good developer, I'd like to test my code, right? Right, indeed. And what can I do in order to test my code? As ordinary, I can write tests. I can call my tests, my code this way, like create an instance and execute some code. I can, for example, say, well, I'd like to mock some dependencies. For example, I'd like to get rid of error legs. That's why I will replace it with var mock. It's also a good option. But what if I'd like to execute my code in the environment which is as close as possible to my real environment? And SAM here helps you. What you can do, you can call SAM local invoke. SAM local invoke reads your file, template.yaml, and says that, I do not understand what exact code you'd like to invoke, what exact function. And here it parses your file and said, well, there are three options, three opportunities. For example, if you'd like to run ingest alerter, what you need to do is just to provide a name to me, just say what function to call, and I will do it for you. Let's wait for a moment and we will see how gracefully it will fall down. I mean, it will not work. Why? Because it is an entry point, first function, and first function requires some input. In order to start execution, it requires end and first and last date. So as you may see, it falls with null pointer exception. So it is necessary to have a way to provide this function with a kind of input. And if you take a look into the code, you will see that here I have a event1.json, which is a simple JSON which I will use for testing my code. This is the actual payload which will be sent to my pipeline in order to kick it off. Well, what if I'd like to provide my function with this data? In order to do it, I need to use -e keyword, -e parameter, and as you may see, my code executed correctly. It extracted a number of identifiers of document which were updated on between a given dates. As soon as my code is built, I need to deploy it. And in order to deploy a code, what I need to do? Actually, almost nothing. I need to write SAM deploy -- guided. Just for convenience, it is just asking what is the name of my app. PAM SAM Java example 2022. In which region? Let it be here. What is the name of bucket I'd like to use for storing my documents? Let it be here, this one. Parameter with table name. As you may see, I declared these things as a parameters in my template. That's why there are some default values, and SAM is asking me whether I'm happy with it. Roll back, save to configuration to the file, environment, and so on. So what's happening under the hood? Under the hood, all my code is uploaded into into S3 bucket. So this is the first step when my code is being uploaded into S3 bucket. If we take a look into the S3 console, this is my Amazon account, and here in the S3 console, you will see that SAM CLI manage default, blah, blah, blah. This is the code I've written, and currently it is uploading. Actually, it should be already uploaded. Some functions like this, for example, last modified, let's sort it in a different way. Yeah, this is it. So there are 3 lambdas and template for me. It is here. And at this moment, nothing has been created yet, but Sam says that I'm going to do this for you. I'm going to create some API of type of API gateway. I'd like to create some functions. Are you happy with it? And if I'm happy with it, it starts execution of the cloud formation template. And here, if I go to the cloud formation, I will see that my template is actually in the middle of creation. So this is what's happening right now. I have, of course, change set. I can, change set, this was change set. I can watch how my cloud formation template is converted into real infrastructure. So as you may see, everything goes quite fine. Template is does not face any issues. So everything is successfully deployed. And what's more important, what's quite interesting for me is that it provided me with this endpoint. Let me copy and paste, copy to the clipboard. It will be useful for us in future. If you take a look into the Lambda functions, you will not see the source code. Why? Because unfortunately, currently, Cloud9 does not support Java, but it does not support Java, but you could, for example, start execute some code right from the console. I have a few saved events here, and if I execute my code, I will get some response from it. So let's wait a moment until it executes. By the way, if you have any questions, please let me know. This is the output. This is my logs, which are sent to CloudWatch due to my dependency, because without dependency, it will not work, unfortunately. And this is what's happening. So report, request, some data, everything looks correctly. Right. What's interesting? Much more interesting to watch into step functions. To take a look into step functions, because they are brilliant, to be honest. What I have here, I have a step state machine. This is my state machine. I have already tried this talk before. That's why state machine is already available here. It was even failed a few times, but for you, I will start the execution from the very beginning. So in order to start, I need to declare start date 2020 10/20 and end date, of course, 2020 8/10/21, and start the execution. Let's take a look what's happening here under the hood. Under the hood, I will see that state machine has been started, and it illustrates how it works under the hood. Or maybe it also illustrates how execution is happening. Of course, as you may see, it checks, it says what exact step is happening right now. So one time, once ingest alerter, which is the first function, was executed, and next for every document, filtering and downloading is happening here under the hood. Sequentially. And also I can go into the CloudWatch and see some data, like this is send message from my, let's say, from my logs, and Lambda is also working as expected. And of course, it was intended that everything is working. My data is also successfully downloading into my test bucket. What was the name of the bucket I said? Stack name, Aberminus 3 bucket 2022. So let me check. Aberminus 3 bucket 2022. Why don't I see my bucket here? But it works, or maybe not. It is a global service, so bucket should be here. Okay. I think it will not change everything. Up. But nevertheless, surprisingly, I don't see my bucket. That's why maybe my Lambda functions will fail. And in order to see how it's going, I, for example, can go and choose a function and choose a processed doc. So I don't see. Looks like it's just a kind of artifact of console because everything is working as expected. And let's take a look into the Dynamo, whether my documents are saved to Dynamo. I also expect to see everything here. Dashboard, table, yeah, table is here. Provisioning is enough. Data, I suppose, explore table items. Data is all here. So works. In common, that's all I wanted to demonstrate, how easy to create and write application using, write and deploy and debug application using SAM. And what's more important, actually, I pay nothing for this application, despite the fact that it uses many components. Because as for me, it is still in the free tier. I'm not using too much disk space on S3. I'm not using too much capacity units in DynamoDB. I'm not exceeding the amount of invocations of DynamoDB of Lambda. If you have complicated application, you of course can split it into multiple stack, deploy and redeploy code and reuse pieces of your code in different places. As you may also notice, it's much easier to write templates for SAM in comparison with templates for CloudFormation. And just a few things in order to start a new application. Init, invoke local, build, and deploy. This is the link. I hope you see it to my GitHub repo where all the code is available. And secure code also goes to my GitHub account. Thank you very much for watching me. Guys, do you have any questions? You're still keeping silence. Maybe you fall asleep. If not, I still, please confirm if you see the link in the chat for the survey. This is a quite simple survey. Why does it not work? Oh, what's wrong? HTTPS. Come on, the link is not working. That's a pity, and nobody said me that. You should send me that the link is to survey not working. Let me check. Does it work now? No. Okay. Let me post a proper link. Again, copy it. And I really need your feedback regarding this event. Oh, yeah, it works. This is the link. So colleagues, please feel free to unmute yourself and ask your questions if you have any. Or maybe all of you fall asleep. As I ordinarily say, please raise your hand if you fell asleep. If not, Benz, do you have something to say?
Hi. Sorry, can you hear me?
Hi.
I'm,
Yes.
It's Vitaly here. Yeah, I was wondering, how do you, maybe I missed that, but how do you handle errors? So, and how do you actually get the report that there were some errors that happened during the process? So, for example, if you have a background process and that runs on a regular basis by timer, for example, how do I know that some operations didn't complete and how I can be alerted of that?
Yeah, thank you very much. That's a really good question. Unfortunately, in this exact demo, it wasn't covered by ID, but idea is the following. You can there are a few options. First of all, you can configure the simplest and the intended way is to handle the situation on your state machine. If some step is not completed correctly, you can declare in your state machine that this is the else step, or this is the catch step, which will be performed, which will be switched to in case of any errors. And your execution will go using alternative scenario, alternative path. This is the first way, but in this case, you will not be notified. The second thing you need to use is CloudWatch alerts, CloudWatch events, and CloudWatch alarms. These two things which will allow you to go through your logs and notify you in any way, for example, by email, by SMS, in case of a particular error message happens, or a particular error message like appeared in your log files. So two things. First of all, it is catch blocks in state machine, and second, it's CloudWatch. If you're speaking about Lambda functions in command, there are a few more things. For example, if your Lambda function is invoked asynchronously, you can also configure did letter queue, which will collect all the messages which were not processed correctly. Like you're sending messages, you're delivering messages to your function using SQS, and you also can configure a separate queue for storing unprocessable messages for future investigation. Hope this answers your question.
Yeah, thank you very much.
Okay, colleagues. So I encourage you to join our community, encourage you to join our community Z page and Teams channel. And I really would like to hear your feedback regarding this first event. Thank you very much for joining. In this case, you will get a recording shortly as soon as I process them. Hope you enjoyed our first session. If you have something to share with us, I mean some talk to conduct, or maybe some interesting technology to share, do not hesitate and do it right away. Thank you very much. I'm very happy all of you came to us today. Thank you.
Thank you so much, Alex. Well done. Have a lovely evening, everyone. Bye. See you in the next one.